What's going on, guys? Let's try this problem right here. We have two different problems. Let's try the first one. In the first question, we have a light that travels from air to glass, right? So when it travels from air to glass, the speed is going to change due to the index of refraction, right? So index of refraction of air is always 1, and whatever the other materials is going to be higher than that. So here for the glass it's 1.6. So let's see what's going to happen to the speed of the light when it travels from air to glass, right? Now to find this one out, we have an equation that is V is equal to C over N. So C is speed of light in air, that is 3 times 10 to the power of 8, right? 3 times 10 to the power of 8 meter per second. And index of refraction of this glass is 1.6. And if you divide this one by this, you should get 1.875 times 10 to the power of 8, right? From this one we know that when it travels from air to glass, the speed is going to decrease, right? Now let's look at the second question. So here we have a light ray that travels with an angle. So here it's a direct traveling. Here we have with an angle, and the angle that makes with the normal is 30 degree, right? Now the question is asking what is the angle of refraction. So the angle that is reflected and making with normal is called angle of refraction. So this angle is the question, right? Now in order to find this one, we can use Snell's law. Snell's law says that n1 sine theta 1 is equivalent to n2 sine theta 2, right? So here we are trying to find theta 2. So in order to find this one, we have to rearrange this. So let's flip this equation around. So if you flip this one, that's going to give us n2 sine theta 2 is equivalent to n1 sine theta 1, right? Now we are trying to find theta 2 alone. So let's bring everything else to the other side. So here we are going to have theta 2 is going to be equivalent to n1 over n2. Also we are going to have sine inverse n1 over n2 sine theta 1, right? Now let's plug all the values. Sine inverse n1 is the air's index of refraction, that is 1, and index of refraction of water is 1.33, and sine 30 degree, right? The angle that is making with the normal is 30 degrees, so that's going to be sine 30. Now if you calculate this one, you should get 22.1 degree. So this is going to be the angle of refraction, right? And that's how we do this kind of problems. I hope this video was helpful to you. See you next time.